Hi, this is Stephen Brower. In Chapter 2, we're going to look at how memory is handled uh, within some older systems, or really simple systems. What we have represented here is memory. This is, think of it as being just a little bit of memory, up to 160K worth of memory, of which the operating system is taking up, in this case, the first 20K. Now, here we're going to take a first look at without relocation, and then we'll look at with relocation. So if a job appears, let's say this job 1 is 20K, it just goes and fits into the next 20K that's available, which is from 20 to 40K in terms of memory locations. Job 2 appears, which is 40K, and it takes then this chunk here from 40K to 80K. Job 3 appears, which is 60K in size, and so it takes the 60K blocks from 80 to 140. Now let's say job 4 shows up. Well, it needs 40K blocks, but there's only 20K available, so it can't go into memory. So we have to wait for a job to disappear before this job 4 can get loaded into memory. Well, let's now suppose that job 1 finishes, and so that 20K is released. We do have a total of 40K, but it's not contiguous. So this job 4 cannot be brought into memory because we don't have 40K contiguous blocks. So we need one of these, either job 2 or job 3, to disappear in order for job 4 to fit in. Suppose job 3 does disappear, and now that there's 40K, job 4 can fit into the 40K. So at the present moment, we do have 20K here, 40K here, we have 60K free, but it's not contiguous. So now if another job shows up, let's just pretend this one is 60K, it cannot fit into memory. So without relocation, then jobs may not be able to fit into memory if there's not enough contiguous memory free. With relocation, so here we have the same memory, but we're going to be able to relocate the blocks. So we'll have the jobs of the same size arriving. So the job 1, 20K arrives. Now, because we are working with relocation, initially when a job is brought into memory, its relocation register is 0. That means that as this job is running, when it goes to adjust any memory references, there's a 0 adjustment because it hasn't yet been moved. Job 2, 40K, is brought into memory. It takes the next 40K blocks. Job 3, which is 60K, takes the next 60K blocks. Job 4 comes along and it can't fit into memory because there's not enough free. So suppose that job 1 does finish. Well, at the moment that job 1 finishes, that job 4 still can't fit into memory. This is where we need to then relocate. In other words, we need to take job 2 and move it up. We need to move it back 20K. We need to take job 3 and also move it back 20K. So job 2 moves up, and then its relocation register is set to minus 20K. Job 3 moves up, its relocation register is set to minus 20K. That would mean in each of these jobs, if a memory reference is ever made, it would then have to be subtracted by 20 to reflect where it currently actually is residing. So then the job 4 does get loaded into memory, and its relocation register is 0. So with that relocation, those job 2 and 3 were able to move up to allow the job 4 to then fit in. Now, at the present moment, if job 5 comes along, it can't fit into memory because there's no memory available. So this little video was just meant to sort of illustrate the difference between without relocation and with relocation when it comes to dynamic partitions.